Hello guys, namaste, DAP, Perev. Anyway, we have a Dell laptop. Let me do this. I'm gonna put a sticker on this RAM because it doesn't belong to this machine. So let me put a sticker here. It belongs to Mr. Mooking. Let me write a name. VE. I know. What does that mean? So, okay. Let's do it, guys. Let me connect to RAM. Let's see what is going on with this machine. I have two identical boards. So I'm going to start with this. And again, it's going to be easy to repair both of them since we have two identical boards. So we'll use the other one as a reference to see and check because both of them are working, if I'm not mistaken. But I think this one has some issues of not allowing the 19 volts to pass. But let's go ahead, let's do it. So what you do, you connect the charger. The charger has been connected. So we need to check the 19 volts. Where do we check the 19 volts here?
So the current two MOSFETs.
Okay, my guy here, he's saying we need to find the current center and the two MOSFETs. Let's go ahead and find the current center in the two MOSFETs. Okay, there we go. Okay guys, we need to check the current center, whether we do have the 19 volts or not. So let's go ahead. Let's start here. We do have the 19 volts. We do have the 19 volts. And if you check, there's a big power rail. It goes all over. Follow my prop, until it reaches what? The first MOSFET. This is the first MOSFET. Let's check. Aibo. Okay, we do have the 19 volts. What about the output of the first MOSFET? See how many volts we have. We have 2.4 volts. All right, guys. I'm asking my guy here to tell us what is wrong with this board because we do have. Okay, let me show you. We have the 19 volts on the input, but on the output of the first MOSFET, we have 2 volts. Even on the current sensor, we have 2 volts. So guys, what is wrong with this board? Can someone tell me what is happening here?
Oh, all right. Oh.
Okay guys, so my guy here, he believed that this MOSFET is dead, of which I don't think that the case. I don't really believe that this MOSFET is dead. This MOSFET is fine, 100%. But he did mention that in case we have a short to ground, the machine will do the same thing. So switch your multimeter into continuity mode, and then this will tell you whether there's a short or not. For example, if you touch another ground, the multimeter beeps and it shows you 0 0. So let's just try here on the current sensor. No short. What about here on the output of the first MOSFET? No short. So there is no short. Okay, we don't have any short. Let me show you where I was checking. So here we have the 19 volts, right? But here on the output, we have 2 voltages. And then this is the second MOSFET. We have 2 voltages as well. Even here we have 2 voltages. So it means there's a problem, but there's no short. I did check here, there was no short. And the reason why the current sensor looks like this is because I did work on this machine before. It came here for a charging pin, for a charging port. The charging port on this machine is damaged, so I'm using my own port right now. And when we changed the port, still it wasn't charging the laptop. And when I checked, I noticed that there was no power going through the port. It's doing the same thing here. We're getting 2 volts here on the output. And the laptop was working on the battery, of which I believe right now maybe it's low, it's no longer charging the battery. But initially when it came with that problem. So guys, why the second MOSFET is not allowing the power to go through? So we should have the power on the gate, right? Guys, this is easy to repair. This is easy. I have a plan. Let me show you something. Let's do this. Let's check this board. Okay, wait. Let's check this board here. This one here. Let's put it aside and check this one. We have 2 identical boards. Let's put the heatsink. Observe la. Lento ngeqhaza la ibalekile yakhona. Ukusiza ukuthi ucabange in most cases. Okay guys, since we have exactly the same identical boards, let's check what the other one is doing, and then we know for sure. We have 2 identical boards. Let's put the thing, the fan. Let's remove the power jack and then connect it. How do we connect this? Okay, the charging pin has been connected. So what do? It's easy. We have the same MOSFET there. So let's see how many volts we are getting there. Turn your meter into voltage mode. You check the charging pin. You connect it. Now let's check, do we have the 19 volts? Yes, we do have the 19 volts. What about, does it reach the first MOSFET? Yes, it does reach the first MOSFET. Now let's check the output of the first MOSFET. We have 20 volts. There we go. On the output, we have 20 volts. What about the current sensor? We have 20 volts. Now, there's the tricky part now. Let's check the gate. Let me show you under the microscope. Let me shift this aside. I want us to check the gate. Then we'll compare the readings between the 2 boards, and then I will be able to see what went wrong by comparing the readings. So far, I'm not sure. Okay, guys, this is the first MOSFET, right? We have 20 volts on both sides on this one, right? Let me show you. Let me show you again. We have 20 volts. We have 20 volts. What about the gauge? Exactly. Now let's check the gauge. 25 volts. So since this is this MOSFET, we remember you have P channel MOSFET and you have what? You have N channel MOSFET. So it means the gate on this one, on this type, should be more than the source, should be more than the input. Since the input is 19 volts. Let me show you again. The input here is 19.7 volts. And yes, 19.7 volts. But the gate should be more than that. It's 25 volts in order to allow the power to pass by. I'm not sure if someone is getting this. Let me repeat again. In order for this MOSFET to allow the 19 volts or 20 volts to pass by, it is being controlled by what? By a gate. And the gate should be more than the actual input voltage. Since it's 19 volts, here you'll get like 21, 22, 23, even 28, but it should be more than the input in order to allow what to be active and allow the power to pass through. We have 25 volts. And now, what about this? Okay, let's check this. Go get parts, boss. $25 volts. What about here? 4 volt to be active. What about here? 19 voltage. So let's go ahead and check the other one, the dead one, because this one is working. We can all see, and we have what? The voltage comparison. You agree, so you're right?
Yeah, I do.
But you understand what I'm trying to do here?
Yeah, I do.
This one is working. It does allow the 19 volts to pass. So I'm trying to compare the readings between the two motherboards. Well, it's only Steve. How's it going? Ngisela phana manje kusinga. Uthi amesihlini. Usesubhena le elinovo na ilapha. Fan. Okay, guys, let's check this one. So I'm not sure if you understand this. Guys, this is simple. I'm comparing the two boards. One is working, both of them are working, but only if you jump the MOSFET on this other one. And this one is fine so far, if I remember very well. It was turning on, but no display on the other one, not on this one. So it's very, very easy to fix a board when you have another board to compare the voltage. So we know what we need to do. I just gave you a tip and a clue. Whenever you're fixing a board, try to find another exactly the same board so that you know what to have, how many volts to have. Otherwise, use a schematic. Simple thing, use a schematic. If there's no schematic, then use another same board. But guys, I'm telling you, this transistor here doesn't look okay. Check the shape, check the edges. It looks like it's been damaged, guys, like serious. Check the edges. Check the edges. I don't really trust this transistor, guys. I'm gonna be honest with you. I don't really trust this transistor. But let's find out. So what you do, connect your charger. Okay, let me start. Check the 19 volts. We do have the 19 volts. What about the output? I saw 19 and then it went away. Okay, it's 2 volt. Now let's check the gate. The gate is 2 volts. It can't be 2 volts. 2.42 volts, and the gate is 2.6. I'm not sure if you are seeing this. The gate is 2 volts and it shouldn't be 2 volts. Should be how many volts?
Should be maybe
25.
25.
Yeah, it should be more than the input. Now let's check this this resistor here. Okay, on this resistor, on this other side, I have 0 volt. Okay, 3 volts, 2 volts, 3 volts. Okay, this should be 25 volts and it's 2 volts. Now this side should be 4 volts, it should be active, and it's not 4 volts. It's not 4 volts, it's just 1 volt. This side should be how many volts? So the side
it's just supposed to be 19 volts.
yeah, this is supposed to be 19 volt, and it's not 19 volt. Okay, let's do this, guys. Let's swipe these transistors. I want to check something, and swipe this MOSFET as well with the other one. I want to see something. Alright, guys, I just swiped those. I changed the first MOSFET. I haven't changed the second MOSFET, and again I changed even this resistor along with this transistor. You can see this is a nice clean transistor, but I just noticed something. If we trace, remember there was a 19 volts here, right? This 19 volts comes all the way from this tray, from this power rail. Goes all over the way until here. So there was 19 volts here on the other board, and I think the reason why we don't have this 19 volts is because this 19 volts is coming from the charging chip as an output. If all things are okay on the board, I believe so. So right now I don't think this board will have what we are expecting.
Check out.
But anyway, let's check before I even change the charging chip, because the issue here is the charging chip. Oh wait, it's turning on. There we go. And the fan is spinning. The machine is working. Okay, but we need to find out. The fan is spinning one way. Yeah, okay. There's the lights. You can see the lights flashing here. No need to check for the 19 volt. We do have what? The 19 volt. Let me just prove it to you. We do have the 19 volts on the current sensor. Aibo. There we go. 19.5 volts. It's fine. Okay, guys. Anyway, now we know what is going on here. We need to check the transistor every time. But remember one thing now. I changed so many things. So it's even hard to tell which one is causing this. So let's ask Sio, which one is causing this? Because we changed 4 things. 1 resistor, 2 MOSFETs, of which is first and the second MOSFET, and we changed that transistor there, of which I said it wasn't looking good. Yeah, so which one is fault?
Okay, for me, I believe what was fault? This was a transistor.
Which one?
Base.
The 3 leg transistor.
Sure.
You mean the 3 leg transistor?
Yeah, the 3 leg transistor.
Okay, guys, so he believe the faulty is coming from the 3 leg transistor. So let's do this. Let's check the MOSFETs. Let's put them back on the other board. But let's check them first. This one is now working. How do you check the MOSFET? Put your meter into diode mode. Let me repeat again. To check the MOSFET, you put the multimeter into a diode mode, because inside the MOSFET there's a diode. So we want to see if the diode is still functioning proper, and see if there's no short or what. All right, guys, let's go ahead. Let's do it. What is this? This is faulty. I can't believe this. Shorted. It can't be. Let's check this one. 526. So when you reverse the probe, there shouldn't be any readings, and there's no readings. But this one is reads on both sides because it's shorted. Okay, guys, the gate is fine. This MOSFET is fine. I believe it's fine. Ile PC Steve. Nazo zasho. Ngangazi yaphila nazo. Ayafana ngizivuma. Ngangazi yaphila. Kungayikhanda. Umthelo uvema ngilombizo 950 sithe umthelo uvema. Sengikhanda iPC yakhe yaphila. Oh, okay. Yeah, I'm paid better because it comes back. Yes. Okay, guys. I really don't believe that this is shorted, but I'm gonna change this MOSFET. Let's fix this board now. We're doing the second board now, the one that was working, I believe so. We took the part from it, so we need to fix it as well. Yeah, boy. Can we find a schematic for this? I'm not sure. Oh yes, let's go online and find the schematics. Yeah, big Cupid. Okay, guys. Here we are. There is a BQ, data. So yes, it's responsible for turning on the gate. Hope you can see. Okay. So what I'm gonna do here. Let's put back all these components. And that one resistor is going to ground, right? And it's a 1 mega ohms, million ohms. Okay. Let's just put everything back together. All right, guys. This is fine. I mean, the issue was that tiny MOSFET, the second one, it was shorted. See, we do have the 19 volt. Let me show you. We do have the 19 volt, and the output, we do have the 19 volt. Even on the current sensor, we do have the 19 volts, meaning I was wrong. That transistor is fine. The issue was just that shorted MOSFET. That's all. Anyway, bye bye. I hope you learned something. But let me show you, these ports are working 100%. Let me just show you, because I know some of you will say, nah, I did the half job. The ports are fine. No, e-port like one, no, e-cover. No, ilele. No, wait, yaprendele. Which one is which? Ngisabone mina manje. Mana? Nah, ilele. Vale, vale. Vale. All right, guys. Anyway, sorry about this. This is turning. This is not even turning on. It's just doing nothing. And I think I know what I did wrong. The issue on this machine. See, there's a light, right? This one is dead, even though the 19 volts has been done proper. But I'll show you now. We installed a wrong motherboard on this board. It needs to be fixed. Okay, the only one that we fixed is the other one, which had the issue with giving us the output of what, of 2 volts. This one it means the 19 volts was there initially, but not showing us, not giving us any display. So this is what we're gonna do. Let's remove this. Estelle, aphetha ilo khona i-ID yakho lapha ngikusebenzisele sim card yakho. Yeah? Kuma into engiyibonayo yabo, it's gonna take long to be activate yabo. So if we do it now, probably after 4 hours or 5 hours or even 6 hours, then we can have a working SIM card. Awuyiphetha? So awuyiphetha SIM card ilo yakho lapha?
It's not ID now.
Angeke bayivuma yazi. Uzifake ephephesini sicelo? Uzifake ephephesini? Eyabani lebo? Oh, ngangithe uma ufuna izinto akutshela usithe ayish mina ngimazi mfethu yazi. Oh, yini lento le? Nah, it's working, done. Low ngiyakutshela nje 100%. Bengenama-issues.